Right, students. So this is going to be a video that shows you how to do the Unit 2 individual assessment if your patients were Mr. Blake, Miss Maria, Mr. Zach, Miss Masiha, and Miss Julie. So the directions here says to read the biographies for each statement, create a diagram to show the connections between patients and their symptoms. So if you go back to 1.11a in your unit review, we actually did this already. Oh, this is 1.11b, 1.11a, unit review. We actually did this together when we were looking at a diagram between patients and their symptoms for the patients that we had, Sue, Jill, Wanda, Maggie, etc. You're going to do the same thing here. So I'm going to draw these here. You're going to obviously draw these with a pencil or with a pen, but I'm going to show you this here. So I'm going to move the drawing right here. So let's see, what do we have here? So the first thing I would recommend that you do is to write the names of your 5 patients. So we have Mr. Blake, we have Miss Maria, we have Mr. Zach, we have Miss Masiha, and we have Miss Julie. All right, so let's find the connections between them. So we're going to do the symptoms and their connections with each other. So these 2 rows. So let's see. Mr. Blake, so he has a sore throat, but it doesn't look like anyone else has a sore throat. So we're going to ignore that for now. Let's look. So Mr. Blake has a headache. Miss Maria also has a headache. Mr. Zach has a headache, and Miss Julie has a headache. All 4 of them have a headache. So I'm going to draw a connection between all 4 of them. Okay, so Mr. Blake, here in the middle. Let's see who else has it. Miss Maria has a headache as well. Let's see, Mr. Zach has one as well, and then Miss Julie has one as well. They all 4 of them have a headache. So here I'm going to write headache. All 4 of them have a headache. Great. Next, so let's see. Miss Maria has the symptom of vomiting, and so does Miss Masiha. So Miss Maria and Miss Masiha are vomiting. So the symptom for them is vomit. Not a fun symptom. Okay. There we go. All right. Anything else? So let's say Mr. Zach has a fever and Miss Masiha has a fever. Both of them have a fever. So I'm going to put a connection between Mr. Zach and Miss Masiha and put a fever. Okay. So now let's look at the connections between them. So the connections between these patients. So here it says that Mr. Blake plays soccer with Mr. Zach. So let's put a connection between Mr. Blake and Mr. Zach. They play soccer. Miss Maria, she's roommates with Miss Masiha. So they live together. Miss Maria and Miss Masiha, they're roommates. Okay. Miss Maria is also friends with Mr. Zach, so we can draw a line between Miss Maria and Mr. Zach. They're friends. Okay. Mr. Zach is friends with Miss Masiha, so let's draw a connection between them as well. Talk about how they are friends. Friends. Okay. And let's see, we have that Miss Masiha is roommates with Miss Maria. We already wrote that down before. And then we have Miss Julie is friends with Mr. Blake. So Mr. Blake and Miss Julie are friends. Friends. Okay. And that's it. Those are all the connections. Your diagram might look a little bit different, but it should still have all these important connections in them. This basically just helps us see, right, who might have infected the other people. All right, so now we're going to look at BLAST. So the directions are to answer the questions by writing complete sentences, write as much as you can in English. So the most common pathogen among our patients. So let's look at our 5 patients and their pathogens. So let's see, we have Mr. Blake has Epstein-Barr virus, Miss Maria has influenza, Mr. Zach has Epstein-Barr, Miss Nissy has mononucleosis, and then Miss Julie has Epstein-Barr. So these three people, so Mr. Zach, Miss Julie, Mr. Zach, and Mr. Blake, them three have the Epstein-Barr virus. So the most common pathogen among our patients is the Epstein-Barr virus. What is the purpose of using BLAST? Well, if we return here to 1.111a, if you look down to number 3 on 1. That asks us the purpose here. You could also go to 1.4 BLAST, your paper 1.4. So the purpose of BLAST right here is what it does is it finds the identity of the pathogen, right? Find the identity of the pathogen. So what I'm going to write here, the purpose of using BLAST is to find the identity of the pathogen. Okay, let's come down here. Let's look at two similarities and differences. So answer the questions by writing the sentences, write as much as you can in English. Use your science connection words. Let's look at our connection words. You have, there's Spanish, there's Arabic. There are various other languages as well. Let's look at our Chinese connection as well. There we go. We'll close this for now. So let's look at our two similarities and our two differences. So similarities, what are two things that these things have in common? So similarities, we're going to use one of these words. Similarities. Any of these words are fine to use. So I'm going to start with using the word two. So let's see. Mr. Blake and Mr. Zach, and Miss Julie, they all have the Epstein-Barr virus. So I can pick any of these. I'll start with Mr. Blake and Mr. Zach. I'll say Mr. Blake has the Epstein-Barr virus pathogen. And then what I can do is I can use the word two. You can put a comma, and then you put and. Mr. Zach has Epstein-Barr virus pathogen two as well. Okay. Word two. Okay, let's look at another one. Let's see. So Miss Maria has Neisseria meningitidis, but Miss Nasiha has Streptococcus pyogenes. So since these two are different from each other, these two are different things, I can put that, I can use any of these words that I want. Let's use the word while, or sorry, where they both of them have a bacteria. Both Miss Nasiha, Miss Nasi, and Miss Maria have a bacteria. Their pathogens are different, but they both have a bacteria. So that's a similarity. So I can look at the word likewise. Let's try the word likewise. So Miss Maria's pathogen is a bacteria. Likewise, Miss Nasiha pathogen is also a bacteria. Right, we use the word likewise. You can use any of these words that you'd like. Any of them are fine. Let's look at differences. So I already gave you one of the differences. We can just use that one. So Miss Maria has Neisseria meningitidis. Miss Maria has Neisseria meningitidis. Miss Nasiha has Streptococcus pyogenes. So I'll use the word while. This time I'll actually use the word while. While. So while Miss Maria has the Neisseria meningitidis pathogen, Miss Nasiha has the Streptococcus pyogenes pathogen. So the word while here, right? The word while tells me that it's about a difference, some differences that are happening. Okay. Let's look at another difference. So let's see. Miss Maria's pathogen has a vaccine, but Mr. Blake's, or let's try Miss Julie's pathogen does not have a vaccine. So that means I'm gonna use the word but to talk about differences. So Miss Maria, or sorry, Mr. Blake, Miss Maria's pathogen has a vaccine, but Miss Julie's pathogen does not have a vaccine. So I use the word but. Okay. And we can move down to the next part. So antibodies and antigens. So again, it's telling us here, answer the questions by writing complete sentences, write as much as you can in English. So antibodies and antigens, if you look back to 1.11a, we did this all the way here at the bottom. You can also look back here at 1.6. We can take out these connection words, so 1.6, antibodies and antigens. So here we looked at the self-antigens, non-self-antigens, antibodies, and blood types that each blood type can receive. So Mr. Zach has blood type AB. What type of self-antigen does Mr. Zach have? So if I have blood type AB, my self-antigens, I have both antigen A and antigen B. So here I will write Mr. Zach has both self-antigen A and self-antigen B. You don't have to write the word self, that's fine. If you write has both antigen A and antigen B, that's fine as well. Miss Julia has blood type B. What type of antibodies does Miss Julie produce? So if I have blood type B, my antibodies antibody A. So I'm going to write that Miss Julie produces antibody A. Then it says Mr. Blake has blood type A. What type of blood can Mr. Blake receive? So let's go to blood type A. Mr. Blake can receive blood type A and blood type O. He can receive both. Mr. Blake can receive blood type A and blood type O. He can receive both. Wonderful. Okay, there we go. Now we're going to go over to concentration. So for concentration, we're going to go over to 1.11b, which is when we did our unit review. So let's start by looking at solutes and solvents. So it says here, so answer the questions. So in this case, you won't need to write complete sentences because these are just math questions. But let's look. So solute is the substance that is dissolved. Solvent is the liquid that dissolves the solute. So the substance that is dissolved is the solid. The liquid is going to dissolve the solute. That's called the solvent. So in this case, right, whatever I add to the liquid is going to be the solute. Whatever the liquid is that dissolves the solute is called the solvent. So the solute, in this case, the solute is, so this is protein. Mr. Zach makes protein shake every morning by adding protein powder to milk to cup 1. So protein powder is our solute and milk is our solvent. To make the perfect drink, Mr. Zach adds 80 grams of protein powder to 400 milliliters of milk. What is the mass, volume, and concentration of his protein drink? Remember to add units. So if we look back here, right, with 1 point, here when we calculated the concentration, right, we put that the mass, right, the mass is going to be whatever the thing is that's being dissolved. The volume is going to be the liquid, and then we can calculate them by using mass divided by volume. So our mass is 80 grams of protein powder. Our volume is 400 milliliters. To find our concentration, we can use our concentration triangle. So concentration is the letter C here. If I cover the letter C, I am left with mass divided by volume. So mass is 80 grams, and I'm going to divide by a volume of 400 milliliters. So 80 grams divided by 400 milliliters. All right. So 80 divided by 400, put this into a calculator, and we're left with 0.2. So I have 0.2 grams per milliliter. That is the concentration of the protein drink. Okay. Now it's telling me that Mr. Zach takes 200 milliliters of protein drink from cup 1 and puts it into cup 2. What is the mass, volume, and concentration of each cup? Remember to add the units. So initially we have 400 milliliters. And what I'm going to do is I'm going to take 200 milliliters from cup 1 and I'm going to put it into cup 2. So since that means that cup 2 now is going to have 200 milliliters, right? I put 200 milliliters into cup 2. If initially I had 400 milliliters in cup 1 and I took away 200 milliliters, I'm left with 200 milliliters. Right? 400 minus 200 is 200. What's the concentration? Well, if I go back to this here, right? If I change the container, so if I just put liquid from one container into another container, that does not change its concentration. The concentration of both of those liquids is the same. So that means that the concentration of cup 1 and cup 2 are the same as cup 1 was before. This concentration is still the same. It's still the same liquid. I did not add any water or any protein powder to it, or I didn't add any milk or protein powder to it. The concentration will remain the same. Okay. Then to find the mass, what I do is I have to use the concentration triangle. So mass, I cover the M with my finger, and I'm left with mass is equal to volume times concentration. I multiply these two. So volume in this case is 200 milliliters, multiplied by the concentration, which is 0.2. So we have 200 milliliters times 0.2. We're left with 40. We have 40 grams of mass, 40 grams of protein in each cup, in cup 1. For the second one, it's going to be the same. So I can show you again, but it's going to be 200 milliliters times 0.2. So I'll calculate it again, and I'm left with 40. Again, 40 grams. We actually did this exact same problem as well here in our question set here when we were looking at number 9C. So if you want to look at 9C, that's going to help you understand how this came about. Now let's look over to ELISA. So this is answer the questions by writing in complete sentences, write as much as you can in English. So here the question is asking us what antigen will the primary antibody bind to? So let's go over to 1.11C in our unit review. In this is 1.11B, 1.11C. There we go. Okay. So in the lab that we did together, right, we were looking at the Neisseria meningitidis pathogen. And so the purpose of our ELISA was for the antibodies that we add, right, the primary antibody would bind to the antigens for the Neisseria meningitidis pathogen. In this case, we are looking at the pathogen Epstein-Barr. So we're looking at a different pathogen. We're looking at Epstein-Barr this time. So we would put that the primary antibody will bind to the antigen for the Epstein-Barr virus. Okay. What will the substrate bind to? Well, if we look here, right, our substrate, what it does is it binds to the secondary antibody. So here, right, we have the secondary antibody that's in the solution. We added the substrate. That substrate binds to that secondary antibody, and that's what causes the solution to glow. So that's what I would put here. The substrate binds to the secondary antibody. Then how will we know who has the highest concentration of the pathogen? So if we go over to 1.9E, when we looked at the ELISA post-lab debrief, so you can also look at the ELISA lab results that we looked at together. Right, so in these questions, what we did was, right, we were trying to figure out who had the concentration of the pathogen that was the highest, and what we found was that the person who had the highest amount of brightness, the sample that was the brightest, was the person who had the highest amount of the pathogen inside of them. So we decided that that was Jill, and that was because her sample had the most color, the most brightness. So we will know who has the highest concentration of the pathogen. And actually, I think we can even look here. It says here, because the brightness of the sample is the highest. Of their sample is the highest. Okay. Which patients are positive for the Epstein-Barr pathogen? So let's look back here. Remember, we were looking at which patients were positive for Neisseria meningitidis, and we decided that all four people, Sue, Jill, Wanda, and Maria, all of them had the pathogen because all four of their samples had brightness. So that means that all four of them have the pathogen. So in this case, we have Mr. Blake, Mr. Zach, and Miss Julie. So I'm going to circle Mr. Blake, Mr. Zach, and Miss Julie. Okay. Now it's asking us what was the brightness of each sample. So the brightness is the number, the numerical answer. So here we also did this on number 4 in 1.9e. So in this case, what we have is that Mr. Blake is 28.2, Mr. Zach is 41.2, and Miss Julie is 9.1. So Mr. Blake here has a brightness of 28.2. Mr. Zach has a brightness of 41.2. And Miss Julie has a brightness of 9.1. Okay. Great. Now let's go over to number 16. For number 16, what this is asking us now is to look at which patient had the highest concentration for the antigen for the Epstein-Barr virus pathogen, and how do you know? So again, we actually did this exact same question right here. So which patient had the highest concentration for the antigen for Neisseria meningitidis pathogen? In this case, we said it was Jill, right? We said it was Jill because she had the highest brightness. She had 54.3. In this case, the person who has the highest brightness is Mr. Zach with 41.2. So that's what we're going to write here. Mr. Zach's sample had the highest concentration of the antigen for the Epstein-Barr virus pathogen. I know this because, well, again, looking here, the brightness of the sample was the highest. The brightness of his sample was the highest. And then finally, who do we think that patient 0 was for the Epstein-Barr pathogen? Well, if we look back here, right, we looked at patient 0. Patient 0 in this case was still Jill because she had the pathogen, she had the highest concentration of the pathogen, right? The concentration of the pathogen was the highest, which means that she was the first person who had gotten sick. She was the first person who had gotten sick. The pathogen has been reproducing inside of her for the longest. So in this case, it's going to be Mr. Zach. Mr. Zach's sample Mr. Zach, or rather, Mr. Zach is patient 0. I know this because the concentration of the antigen was the highest for him. This means he was the first person to get sick. So that means that, right, the virus has been reproducing inside of him for the longest, right? The virus has been inside his body for the longest. And that's about it. Well, hopefully this was helpful, students. I'll see you soon.